Hello ladies and gentlemen, welcome to our lesson about graphing hyperbolas. You should get out your notes and open up to this page of it. We're going to be doing some graphing today. We're not going to do all the things that are in your notes today. We're focusing on the graphing and then writing an equation based off the graph. First things first, you need to know what a hyperbola is. These are hyperbolas. Hyperbolas. Actually, don't know plural of that. But the definition of a hyperbola, it's the set of all points. The big thing about it is, remember how we had ellipses? Well, a hyperbola is like an inside-out ellipse. Instead of all the points being on the ellipse being the same sum of the distances between the foci and the points, the difference between the distances is the same. So, for example, say we got this point here, and we had these two foci. The distance between if you subtract the distance between the foci and a point on there, it's going to be the same. So let's say this distance was 10 and this distance was 2. That difference is 8. And if you were to pick any other point on there and you figure out the distances between the foci and that point, say this is 12, and that would have to be 4 because the differences are always going to be the same. The difference is going to be 8 in this case. Not that those are the actual distances there. But yeah, it's kind of the definition there. To really get at this and be able to graph it, you have to know a few things about it. Hyperbolas also have vertices, just like your ellipse, just like parabolas. There's a vertex, it has vertices on it, and the length between them is called the transitive axis. Hyperbolas also require you to know things about, hyperbolas also have things called asymptotes. And these asymptotes here, they're lines they get infinitely close to but never cross. They never touch them. And if you were to use your slopes of those to make a box that hits your vertices, you would have another little axis here, and that's called the conjugate axis. And we'll get to how to get all those values in just a moment. But first, jump to this part. We're going to be graphing in a hyperbola that is centered at 0, 0, because it's kind of got a simplified equation. These equations are really similar to the equations of ellipses, except instead of in the middle having plus, it is subtract. And that's an important thing to note, because sometimes in the future you're going to be given an equation and you have to notice, is this an ellipse or is this a hyperbola? And the key is that add or subtract in the middle. If it's subtract, it's a hyperbola. And then which of these comes first, x or y, determines if your hyperbola opens horizontally or opens vertically. It's just like an ellipse has a horizontal. The horizontal can be longer or the vertical can be longer. On a hyperbola, it can open horizontally or open vertically. And the way you can tell is x first or y first. If x is first, it's a horizontal hyperbola. If y is first, then it's a vertical hyperbola. And in the equation, again on the bottom, you have a squared and b squared. This time, though, whatever is first is a squared, and then whatever second is b squared. And that's going to be important when you're drawing it and when you're writing the equation for it. And then the next important thing we're going to use today is this asymptote. So the asymptote, these are these dotted lines that go diagonally. They're the ones that's getting infinitely close to but doesn't cross. You're going to need those because you're going to be graphing so you don't hit those, but you do get closer to them. So you will need to get those. So let's do this example that's on your notes, and then we'll do a couple from your assignment. First things first, we need to make sure it equals 1. So we're going to divide everything by 36. Divide everything by 36. And 4 over 36 is 1/9. So we're going to get x squared over 9. And then 9 over 36 simplifies to be 1/4. So we're going to have y squared over 4. That's going to equal 1. Luckily on this, our center is at 0, 0. And that's because there's nothing in here with the x squared and y squared. And then since this number is under the first variable, that's going to be a squared. So a squared is going to be 9, which means a is 3. This number is under the second one, which means that's b squared, so b squared is 4, which means b is 2. So that we have that, we can get our vertices. So your vertices are going from your center, and since this is a horizontal ellipse, because x squared is first, not horizontal ellipse, horizontal hyperbola, you're going to take your center and you're going to go right and left the a distance. If you look at the note part, it's got that. So negative a and positive a, and then we'll get the foci in a sec. So your vertices are hanging out at negative 3, 0, and 3, 0. And then we're also going to get our asymptotes. And the asymptotes are going to be y equals, since this is a horizontal ellipse, horizontal hyperbola, our asymptotes are going to be plus or minus b over a times x. So we got plus or minus 2 over 3, because it's b over a, x. So those are the equations of our ellipses. Sorry, the equations of the asymptotes. Man. Right, so we're actually not going to get the foci right now because we're just focusing on graphing. But you're going to put a dot on the center, and you're going to put a dot at 3, 0 and negative 3, 0. And just like if we're going to draw an ellipse, we're going to go up and down that b distance because that helps us draw our box. So we draw this little box that goes vertical from the vertices and horizontal from our b distance here. And that's going to be useful because that helps us graph our asymptotes. They have the slope of b over a, which is where the corners of those boxes are. So now that we have that, we can actually kind of bold our vertices. They're at 3, 0, negative 3, 0. And we're going to draw a curve that goes out and goes close to our asymptote. And you can do the same on the other side. And the same on the other side. And you've graphed your hyperbola. That looks terrible. But on the next one, we're going to do better. So jump to the next section. This one's the exact same information, except it's not centered at 0, 0, it's centered at hk. So just like when we had ellipses, the number in there with the x is the h, and the number in there with y is the k, and it doesn't matter whether it's k first or h first. Sorry, it doesn't matter if it's y first or x first. K is still with y, and h is still with x. But now you have this slight variation. That's just going to tell you where the center is, but then you'll go right and left A and then up and down B or whatever we got. So let's go through our process of graphing, and this is actually on the assignment. If you haven't got the assignment yet, get the assignment out and go to number 5. First things first, find the center A and B. So the numbers in with x and y are your h and k. This one's h, this one's k, which means our center is hanging out at 1, 3. Let's go over to 1, 3 and put a dot. The number under the first one is a squared, and so the a value is going to be 2. You just square root it. And then the number under the second one is b squared, and so b is going to come out to be 4. You just square root it. And this is an example where a is not bigger than b. On hyperbolas, a does not have to be bigger than b. A is just the first one, and b is the second one. So that's something to remember. So we're going to go from our center, we're going to go vertically an a distance since it's under y. Just like when we have an ellipse, whatever's under y is the vertical part. And then we're going to go our b distance horizontally, because b squared was under x. So we can go right and left 4. 1, 2, 3, 4. And we're going to use that to draw a box. Box, 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 box. So now we have our box. We can draw our lovely asymptotes. They just go across the corners. Keep going. They are going to hit at the center there, so make sure you're hitting the center of our box. We got our lovely asymptotes here. So now we have that. Let's go ahead And make sure we're keeping track. Is this a horizontal hyperbola or a vertical one? The way you can tell is what variable's first. It's y first. So this is going to be opening up and down. And the vertices for those are going to be at the top and bottom of our boxes, lined up with our center. So now we have those. We're going to draw a curve that goes out towards our... Oh man, this is not looking very curved-like. At least not smooth enough. And you're going to draw your curve so it goes towards your asymptotes. It's not going to look like really good, but that's okay. Just try your best. Just realize it's this one's pretty wide. That's because B was bigger than A. We're going to do one more, and that's going backwards. If you go to the back of the assignment, you'll have this one. It's number 9. Step 1, find the center. Pretty easy. You just find where your asymptotes intersect. And you do have to notice what type this is. This is a vertical hyperbola, which means it's going to be y first and x second. Subtract there. It's going to equal 1. Line there. All right. And now we have our center, which happens to be at -2, 1. We can put that in our equation. We're going to have y minus the k value and x minus the h value. X minus -2 is x plus 2 squared. And now we just need to find our a and b values. Since it's a vertical hyperbola, the a distance is going to be the vertical one. And then our horizontal distance here for our box. I don't know if you can see the box, but it's in there. That's going to be your b value. So a is 4, which means a squared is going to be 16. Our b is 2, which means b squared is going to be 4. So b squared goes under the x part, a squared goes under the y part, and voila, we have our equation. So a bit faster to go backwards than actually graph it, but there you go.